Final number 2. So I've got f of x equals square root of x plus 3 over square root of x. Then f prime of 4 is equal to, right? So I'd rewrite this before I bother to take the derivative. I would go x to the 1/2 plus 3x to the negative 1/2, right?
Right.
And then I would take the derivative. Means I throw the 1/2 out in front, x to the negative 1/2, plus throw the negative 1/2 out in front, times x to the negative 3/2, right? All right, plug a 4 back. So if I want to rewrite it so it's in a form I'm more familiar with, I might do this. Oops. Minus 3 halves square root of x cubed, right?
Got it.
All right, plunk a 4 in there. I get 4. Square root of 4 is 2.
Right.
2 times 2 is 4, so that's just 1/4. Plug a 2 in here. Sorry, plug a 4 in here. It becomes a 2. 2 cubed is 8. Times 2 is 16. So I get 3/16.
Which simplifies to 1/16.
Now I need a common denominator, so I would go 4/16 minus 3/16, which is 1/16.
Right.
Hopefully that's the right answer.
Yeah, that's good. So appreciate it.
No props. Ready, Johns? Are you sucking up the ambiance of everybody else? Ambiance sucking up. Okay. Jeremy, got one for me?
I'm working on one right now.
On the final, number 7. F of x equals x squared minus 4. G is a differential function of x. Find f of g of x. Question mark. Okay. So we're going to put g inside of this, right? So there's going to be a g of x here, right? So how do I go about this, especially considering I don't even know what g of x is?
Just be g prime squared, right?
100 derivative, right? We'll check that. Yeah. Okay. So it would be 2, g of x times root of the inside, which is what?
G of x.
G prime of x, right? Because it'd be the derivative.
Right.
So hopefully that's one of my answer choices. Looks like D.
Yeah.
Make sense?
Yeah, I just forgot to
Chain
G
rule.
prime. Yeah.
Chain rule. Chain rule.
Got it.
It's okay. Your score is going up by the second. You're right there, right next to the borderline. It's gonna work.
All right.
All right. What's the next one, Brandon?
Can we do 8 as well?
Let's do 8. I've got a slope field, and it says something like I dx equals y squared, 4 minus y squared. If y equals g of x is the solution for a differential equation with the initial condition g of -2 equals -1, then the limit as x approaches infinity of g of x is equal to, wow. Well, my first instinct to do as follows. I look at the slope field, I see that at -2, I go -2, -1, and I follow my cute little arrows.
Right.
And what does that tell me I'm heading towards?
To 0.
Towards 0.
Yeah.
Any chance it's the right answer?
Yeah. All right.
Got stolen!
I just wasn't sure exactly when they have all the other stuff there.
Yeah, well, it's a slope field, but remember, slope field is an infinite number of solutions. When they give you a spot, then you kind of go, well, that's the limit as you approach infinity. I'm like, how am I going to do that? I'd have to integrate that. And it's got y's in it, and I have to do that separation of variables, and that would be really, really hard. It's just everything about that's a nightmare.
That's what I tried to do.
Ultimately, the only way I could think to do it is just to
Check on the.
draw with my finger and go, what? Oh, looks like it's going to 0.
Okay.
Good?
Yep.
All right. Jeremy, still good?
No.
No? All right, Jeremy, what's the problem?
25 on the section test.
25 section. 7 and 8.
What? No, another section test that has like a section block in the top right corner. So that's the new test.
They all say sectional. One of them says it in big black. Looks like this. See a circle? That's it. Which one is it? 25 you said? 25. Oh, this one. God, sometimes I wish I was just a better teacher. You guys,
I don't know. I said I tried it. It didn't work.
it makes me want to cry and throw up. Okay, so it says that x equals 2, it's differentiable. So to be differential, it must be what?
You can take this continuous.
Must be continuous and must have the same slope coming from the left and right, right? So I'm going to do first continuous. Continuous at 2, right?
Right.
So replace the x with 2. Replace the x with 2. Whoops.
Right.
Can't solve that though. Bummer. 2c plus d equals 4 minus 2c. I get 4c plus d equals 4. That's as far as that one's going. Can't solve it. Because I have how many variables?
2.
Need another equation.
Yep.
What's the other stipulation you had for me?
Yeah, the slopes are the same.
The derivatives must be the same. Agreed?
Right.
At 2. So what's the derivative of the top function?
That's just c.
C. What's the derivative of the bottom function?
2x minus c.
2x minus c. So I get c equals 2, and I got to put a 2 in there minus c.
Okay.
I get 2c equals 4, c equals 2.
Plug it in and solve it.
Okay.
Solve for d.
Thank you.
And pretty much this is on most of the practice exams. And one the numbers have been changed or whatever else, but it's on a lot of them. So just be aware that's a fairly common problem. Brandon,
12 on the final.
12 on the final. The final 12. Final 12. Y equals cosine 2x. On the interval from 0 to pi over 2, I want to find the average of this function. How do I find an average of a function?
This is the one where it's like 1 over b minus a.
Yes. If I want to find the average of the thing that's in front of me, not the average rate of it, but the average thing, then I have to drop it down 1. To drop it down 1, I use that formula. I go 1 minus over pi minus 2, pi over 2 minus 0, right?
But this is the average rate on this question, right? What's the average rate?
Oh, average rate. Never mind. I lie. How do you find the average rate of something?
So that's just the MBTs sort of.
Just plunk it in.
Okay.
So I plug it. Pi over 2, what's cosine of 2 pi over 2? What'd you get?
1.
No.
I don't know.
Really?
Oh, wait, that would work.
Oh. Right, so that's the setup. Cosine of pi is negative 1. Cosine of 0 is positive 1. Flip and multiply. Right, negative 4 over pi. You guess it's the right answer?
Yeah.
All right.
I got it.
All right.
I just forgot the negative on it. I put 1. Ended up being. Just got it.
All right. Jeremy good?
Yeah, I'm just not talking
Jones
about
good?
I'm not good.
Jones, what are we doing?
A limit. I don't know which test this is because they all have weird names.
Okay, that has a number. Look at the edge of the paper.
Like the top edge.
On the top edge.
Mm-hmm.
Okay, no.
No. Close it.
Close the test.
What color?
Now look at the top edge.
Like very
Top edge. What's the edge? There you go.
Green.
Green. That's the green test.
This is so simple.
Well, it is if you can find the green. It's not if you can't. It's a complex system if you can. Now, I would recommend writing green across the top or something, so you don't have to do this every time. But, whatever. So green, what number one? What
Yeah.
number?
Number 1.
Green number 1. Green number 1.
Limits are confusing and make no sense.
Limits. Which type of limit? Is it an infinite limit or the other kind?
It's defined. It's as
Limit
x
as x approaches 2 of x squared plus x. Nope, not yes, plus x minus 6 over x squared minus 4. So I look at this little limit and I go, plug a 2 in.
I did that.
2, 4 plus 2 minus 6 is 0. Oh, that's ominous. Put a 2 in there. Oh, 0, 0, indeterminate form. So the next thing I do is I factor top and bottom because it's not to infinity. So I'm going to factor top and bottom.
And then if it can't factor, do you conjugate?
Then I check to see if it's one of my identities, which just isn't.
Right.
And then last thing is I just pick big numbers. I pick numbers close to 2 and figure out what's going on.
Okay.
That would be the desperation move, especially that calculator does. It's unlikely they would throw that at you. But we're going to factor it anyways because I got x plus 3, x minus 2, and I got x minus 2, x plus 2, right? Because that's the difference between squares. Limit as x approaches 2. All right, notice those 2 cancel out. Also, by the way, it's a cute little hint. If I put a 2 in, I need whatever cancels that out. So it's going to be x minus 2 is probably the one thing I'm going to want to get rid of. Okay? So then I've got a limit as x approaches 2 of x plus 3 over x plus 2. How do I get rid of the limit now?
You plug it in.
Plug it in again. And I get 5 over 4, which is hopefully the answer.
Whoa.
Whoa.
It's a whole new world.
A whole new world.
Next guy.
All right, who's next?
So a lot of time.
Brandon?
Gee, that's pretty. Can we do 15 on the final?
15 on the final.
Similar to this one.
Focus on the final. 15.
Do the numbers in these tests ever like actually go in order instead of skipping like 30 problems?
No, it's always when you go from the calculator to non-calculator calculator. There used to be problems in between. And AP Central and that has never changed the format. What happened is they just deleted all the problems in the middle. And so every time they changed format, they changed the numbers and they added a chunk on the end. Because the advent of graphic calculators was the last advent. That's why you have a calculator section that starts at whatever number it starts at. 14 is the answer? Question?
No, 15.
15. So this is the final 15. F of x equals, oh look, 3x minus 2, look familiar? ln 3 minus 2 at x approaches 1 as x is greater than or equal to 1. Okay, so let the function be defined above, which defines statements about f is true. The limit from the left and the limit from the right is the same. That's what it says, right?
Right.
So, the limit from the left, as I approach this, I'm approaching 1, right? If I plug a 1 in here, I get ln of 1, that's approaching 0.
Right.
Is the limit from the left and right the same?
No.
No, so that's gone.
Yeah.
Next step, it says the limit as I approach from the derivative from the left and the derivative from the right is the same. Crud. That means I got to take a derivative, doesn't it? I'm going to put a 3 in here.
Okay.
That's the top one. What's the derivative of the bottom one? It would be 1 over 3x minus 2 times the inside, which is 3, right?
Okay, that's what I've forgotten there.
So I throw a 1 in there, and I get 1 over 1 times 3. They're both approaching 3, so number 2 is true. All right.
And then number 3 is also false.
Number 3 is differentiable. Well, it's not approaching the same point, so it can't be differentiable.
Right.
It's not continuous. Good?
Yep.
All right. We're on a roll. Oh, I think I'm just about done with this one.